Hi, welcome to the Calculus 1 lecture series. And this is lecture number 9. And this is the second lecture for the unit number 2. We talk about the derivatives. Our previous video, we talk about the two very handy formulas. One is the power rule and other is the derivative about the exponential function, the EX functions. Like I mentioned from the previous video, we love the EX function because the derivative will be itself. So it's pretty easy and pretty cool functions, right? Okay, so today we're going to talk about the product and the quotient rules here. Okay, so let's go ahead and start take a look at our lecture notes here. So what is the product rule? That means, from the previous lectures, right? We say, hey, if you have a constant, if c to the f of x, right? So if you take the derivative of this one, we say, hey, you can just leave the c constants, and then you just take the derivative of the functions, right? That's what we call the constant multiplication. So the product rule, so what is the product rule mean? That means if you have the two functions, also from the previous lecture, we said that if you do like two functions, if you add or minus two function, you can basically bring the here. So you say this is f prime x plus or minus g prime x. See here, that's what we call it the sum rule or difference rules here, right? So now what is the product rule? So the product rule is like if you times two functions, f of x, gx is here, then you take the derivative of this function. Unfortunately, this is not equal to you just take the derivative on both, then multiply it. Unfortunately, it's not, okay? So now, what is the product rules here? So, okay, I'm going to write it out, the product rules here. Okay, so so here, okay, so the product rule, let me put the function in color so we can color code that. And so maybe we'll give you a better ideas here. Okay, so in here, the first things here we do is we take the derivative of the first functions here. So it's f prime, f of x. Then I keep the second functions unchanged here. Okay, so the unchanged function, I put the gx. So the one is changed. I put the maroons here, the purple colors here, all right? And then plus, I keep the first functions unchanged. So it's f of x. So my first function is yellow function. Then times what? I take the derivative of my second function gx here, right? So this purple color will tell you I'm taking the derivative. Then the other color means I'm unchanged that, right? So let's see, that's what is the product rules, right? So that means I take the derivative of the first one, hold the second one still, or I hold the first one still, take the derivative of the second one here, okay? All right, so now, okay, so let's take a look at the quotient rule. What is the quotient rule? Quotient rule, that means if you divide two functions, this is f of x gx here. If you take the derivative of that, then what is that? Okay, so just like before, I'm going to color code that. So maybe we'll simplify to help you to understand that, all right? So for the quotient rule, you can, unfortunately, this is not equal to the f prime x g prime x, right? So don't ever, write this as the answer. Unfortunately, they are not. Okay, so now let's try to write down the correct formula. So the correct formula will be, all right, so you square the bottom. Okay, so you square the bottom. Okay, the square. So I'm going to use a different notation. So you just square the bottom, all right? And then now the top here is you take the derivative about the top, just like your product rule. You take the derivative about the top, then hold the bottom still. Okay, so hold the bottom still. So that's gx is still. The one you take the derivative is the purple color. And then in here, instead of plus, you minus, right? So you minus, you hold the top, nothing changes, right? So hold the top. So here, and then you what? Then you take the derivative of the bottoms, right? So you take the derivative of the bottoms here. And as you can see, and also the big differences here is this is a minus, right? This is a plus. But if you can see the patterns here is very similar. So the quotient rule and the product rule, the quotient rules here tell you the bottom you need to square first. Okay, then the top is just like you do the product rule, but be careful, you have the negatives here. Okay, now let's go ahead and try to practice. Like we say, after several, you will be good at it. All right. Okay, so now the first one's here. Let's set df of time g is equal to this one. This one is false here. Here, some people might get confused is you don't know how to interpret this one. So d, the f of g, the dx, this is really means just f times g to the primes, right? And then this df dx, this is just f prime, and the dg, this is just g prime. So we say this is not equal to the f prime times g prime. That's why we have we call this the product rules, right? So that's the notation. So we say this is false here, okay? All right, so now let's take a look at number 4. Number 2 here. Let's take a look at basically all these 6 problems is just practice, 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 right? Okay, so here, let's see here. Some, for the beginner, I typically like to color that. So this is 5x4. And then this is my 2 functions, correct? So if you color code that, probably maybe it's a little bit easier. So let's see here, f prime x. All right, what you need to do, take the derivative of what? The first one. So what is here? 5 times 4 times x to the 4 minus 1, holding the second one, x plus 1, right? Holding the gx, then plus hold the first one, then take the derivative of this one. So this is x to the first power. So this is 1, the x1 minus 1. So what is this one? Is zeros, right? Okay. So now you can have, this is 5 times 4. This is 20, x to the third, x plus 1. Now, remember we did this many, many times. So what is this one? Is once, right? Okay, so this is plus 5x what? 5x4. Right, so some people might want to simplify a little bit, that's fine. Or you can just, so you can say, I can have a 5x3, right? So 5x3 take out. So what is this one have here? This is have 4x plus 1 plus 5x3. You have x here, right? So you can simplify this like a 5x3, 4x plus, so it's a 5x plus 4. Okay, or you can just leave like that. All right. Okay, so now let's take a look at the second one here. So like I say, if you color that, so if you color the function, so it will help you to make so it's easier for you try to do the derivatives here, right? So let me separate that out. Okay, so this is so let me go back here. So this is f prime x. So what I need to do, take the derivative of the first one. So x squared, so it's 2x. So what is x? X is 1 and minus 1, so it's 2x plus 1, right? Holding the second one, so 3x plus 1. Then plus the first one, hold the first one, x squared plus x. What is here? 3x plus 1, the derivative is 3, right? Okay, so in here, if you want, you can simplify a little bit. So you can just say here, this is 2x plus 1, 3x plus 1, plus x squared plus x times 3. Okay, so like if you want to use your algebra skill to combine and simplify and combine, that's fine. Or, just as long as you know how to do that, that's fine. Okay, so now the next things here, C is here, right? So this is the quotient rules, right? So the quotient rule, so it's x cubed, and let's color code that. This is x squared plus 10 here. Okay, so now the f prime x here. So what is the first step? You square the bottom. So it's x squared plus 10 to the square. Okay, so now you take the derivative of the top. So x3, so it's 3x squared times gx. So this is x squared plus 10, right? Then minus, you hold the top, x cubed, then times, just take the derivative of bottom, what here is give you the 2x here. And then the product rule and the quotient rules really is not too bad. And the tough part is try to simplify it, right? So, okay, you FOIL it. So this is 3x4 plus 330 x squared minus 2x4, right? So if you simplify that, so this is x squared plus 10 to the square. So just be careful, don't make the mistake, the algebra mistake. So this is 3x4, this is minus 2x4. So I will have x4, x4 and then x squared, so I can take the x squared out. So this is x squared minus 30, right? Okay, so you can simplify, combine. All right, so let's take a look at this one again. So they are all the very similar, same old, right? So you just need to be careful about your algebra part. Okay, so now for here, let's take a look at this one here. So this is f prime x here. So let me see here. Okay, so let me try to get some more space here, maybe. Okay, all right, so that's good. So maybe we can have more space to write. Okay, so let's take a look here. Okay, f prime x, so what do we need to do? Square the bottom, right? Okay, so 2 minus x negative 2 to the square. Okay, now you take the derivative of the top. So 1 is a constant. So this is negative 1 times x, the negative 1 minus 1. So it's negative 2 times 2 minus x negative 2. Okay, then minus, right? You hold the top ones here. The top one, this is 1 plus x to the negative 1. Then take the bottom. So 2 is a constant. So it's negative. You put a negative 2. Then here, this is negative 2 minus 1 is negative 3. Okay, so that's what you just need to be careful about your algebra. Hope that I'm not making any algebra mistake here. So this is minus 2 to the square. So this is, okay, so minus, so this is minus 2 to the x square. Minus is a positive. So positive 1 over x4, right? Okay. Then minus, this is 1 plus 1 over x. Then minus minus is 2, so it's 2 to the x cubed. So if you like, you can combine and simplify it. And here, I'm not going to spend the time to the algebra part, okay? Now the f part, so I'm doing this ones here. Okay, so here, all right. So the same things here, right? So if you always color that, it will make you easier. So what is this ones here? So you have f prime x is equal to square the bottom. Okay, so you square the bottom. Okay, so here, this is x plus 1, you square the bottom, right? Then you take the derivative of the top. Okay, so the top here, so this is square root of x, right? Square root of x is x to the 1/2. So you say 1/2, then the 1/2 minus 1 is negative 1/2. Negative 1 is 0. Okay, and then times x plus 1 minus you're holding this ones here, then take the derivative of here. So this is 1/2, right? And then here, what is here? X to the negative 1/2. Correct? All right. Now that you can simplify a little bit, so this is x plus 1 to the square. So this 1/2 you can put on the bottom here. Then this is the x 1/2 x, so this is 1, correct? 1 plus x 1/2 times 1 is like this, right? Then minus this 1/2 will already move here, x 1/2, so what is here? This is 1 minus the square root of x here. Like I say, if you want, you can simplify a little bit. Okay, so for the f here, so this is what? This is the how I love the product rule. The product rule is a lot easier from the algebra point. Okay, so now let's take a look. So f prime x, take the derivative of the first one. What is x squared? 2x, yay, ex. Then plus, hold the first one, x squared. What is the derivative of ex by itself? Oh, I love those things. All right, so now this one is easy to simplify. Also, you can take the x and the ex out. So this is what? 2 plus what? 2 plus x. Okay, that's cool. Okay, the last problems here, let's say find the tangent line of the f of x and x equal to 2. Every time when we want to find the tangent line, I need to find the slope. So in order to find the slope, what I need to do, I need to find the derivatives, right? So f prime x here. So here this is x plus 1 square the bottom. Okay, so the top, you take the derivative of the top is 4. Then this is x plus 1. Then minus, you hold the top, 4x. Then x plus 1, you take derivative, is 1. That's right. Oh, this one seems simplified to the pretty easy one. So this is x plus 1. So this is 4x plus 4 minus 4x. Oh, I like this type of the things. So this one's here is 4, the x plus 1 to the square. So now the x equal to 2, so f prime equal to 2, this will be 2, 4, the 2 plus 1 to the square. So what is here? So this is 4, 9. This is the derivative. What is here? This is the slope of the tangent line. In order to get a line, what next we need? We need a point. So let's put the 2 in the function. So here, this is 4 times 2. 2 plus 1, right? So what is here? A3. Okay. So what is my point here? My point is 2 to A3. So I use the slope and the 1 point. So y minus y1 A3 is equal to the slope 4/9 times x minus 2. All right, so that's it. And if you want to simplify, you can simplify. You can say y is equal to 4/9 to the x minus a/9 plus a/3. Okay, so now if this is 4 over 9 after x, so the a minus, so this is will be what? So this will be the positive 16 over 9, right? So if you find the common denominator, so it's 24 minus 8. Yeah, so it's 16 over 9 here, all right? So this is my tangent lines here. Okay, that's it for these sections. Like I said, the product rule and the quotient rule, in fact, the rule is pretty simple. And like I mentioned before, when we're doing those problems here, what is the tough part? The tough part is your algebra, right? So after you apply the rule, then you need to use your algebra, try to simplify, try to combine. And sometimes those type of the place you will make mistakes. Okay, so be very careful about your algebra here. Okay, that's it. And then we're going to talk about some more rules in our next video. It is nice to talk to you and looking forward to the next video. Okay, bye.